Hey y'all, we're going to go over Newton's universal law of gravitation in this set of video notes. So Newton's universal law of gravitation provides us with this formula here, which is the force of gravity equals the gravitational constant times mass 1 times mass 2 divided by distance squared. So it's the mass of the two objects, generally planets or maybe a person standing on a planet or another object, and then they're separated by a set distance. The gravitational constant G is always going to be 6.67 times 10 to the negative 11th newtons times meters squared divided by kilograms squared. And you'll use that every single time in this formula. It'll never change. What will change is your masses or the distance between the two objects. Generally, the further apart the objects are, the smaller the force of gravity is going to be. The bigger the masses are, the greater the force of gravity is. So if you doubled the mass, you're going to have a much stronger force of gravity. If you double the distance between them, you're going to have a weaker force of gravity. If you kind of think of it as like magnets, the closer they are, the stronger that force is between them. Something kind of like that, but not exactly. All right, so let's go through an example of a word problem that you might see on your test. So in this problem, we have determine the force of gravitational attraction between the Earth, which has a mass of 5.98 times 10 to the 24th kilograms, and a 70 kilogram physics student if the student is standing at sea level, a distance of 6.38 times 10 to the 6 meters from the Earth's center. So we've got our formula. Sorry, this isn't formatted great on the PowerPoint. Then your force of gravity equals, and we plugged in the gravitational constant, we've plugged in the mass of Earth, and the mass of our physics student. Again, it doesn't matter which order they go in. You could have put the 70 before the mass of the Earth. And then we're going to divide by our distance and square that distance. One of the most common mistakes I see students make is that they forget to square the distance, so don't leave that out of the formula. So you'll type all of that into your formula, and you should get an answer of 685.9 newtons. All right, so that's it.